So next up, we move to California, land of innovation, of course, famous for its embedded fuel policy price. And Roger Aines is from Lawrence Livermore National Laboratory. He's in charge of the energy research program, and he's had a long and experienced history in trying to do climate mitigation and carbon storage. So Roger will tell us how he's going to plan to make net economically feasible.
Thank you, Stuart. So we've heard a lot in this meeting about where negative emissions are going to end up, and that's a really valuable thing to think about, but I prefer to think for now about how we're going to start. How are we going to get this going? How are we going to create these industries, these businesses that are going to remove billions of tons of CO2 from the atmosphere? This takes industry, this takes investment now. As we saw from Sabina's talk this morning, we have to start now. How are we going to do that? And I'm going to talk about one mechanism for doing that, which is available very soon in this fall, and that is the California Low Carbon Fuel Standard. And I'm going to give you a very short tutorial on what that is, because I know all these national systems are a little obscure, and this one's among the more obscure, although ultimately I think you'll find it's relatively simple. Basically, the idea is California's trying to reduce the carbon intensity of our transportation sector. And in California, if you include refining and oil production altogether, it's half of our carbon emissions. So it's something we care deeply about, and it's a fraction that's increasing, so it's getting worse. The way we do this in the current low-carbon fuel system is basically to add biofuel to our petroleum to reduce its carbon intensity. The important thing about this system is that the rule applies to any fuel sold in California. The biofuel can be made anywhere. Originally, we were getting a lot of ethanol from Brazil. That's no longer true. Another really important thing in this venue is that it's a very high-priced system. It trades in terms of tons of CO2, and the typical price is around $120 a ton. As of this morning, it was $160 a ton. And negative emissions count. It's a cap-and-trade system, and the more negative you get, the better, more credits you get, the more your fuel is worth. I don't know of any other systems in which that's true, in which doing a better job gets you more money. And in fact, Oppo gave a very good example of something where doing a better job could cut you off just now. So here's the little tutorial on how this works, and I apologize that Oppo and I have used different sign conventions. For me, this is lower carbon, and Stuart is higher carbon. So there's a standard. It's a cap-and-trade system. You have to meet the standard. If you don't meet the standard, you cannot sell fuel in California. So how do you do that? If you add some biofuel to your petroleum and you get a lower value than the standard, then you generate credits that you can sell. And those credits are, again, priced in terms of tons of CO2 avoided. If your fuel is above that standard, you have to buy credits from someone who generated more than they needed, and that's where the free market comes in. That's where the price comes in. Those are traded privately, and that's what the $120 a ton exists. But you can't sell the fuel in California if you can't meet that standard, if you can't buy credits. And the fun thing about this is that the standard decreases every year. It's a moving target. This is intentionally done to get started and then to keep driving to lower and lower levels and new technology. I mentioned the fact that we used to buy Brazilian ethanol. We don't anymore because it can't meet the standard anymore. The historic compliance line shown in blue here, there's a level place for 2 years there where we're being sued by the oil companies. Those suits were resolved. The standard then turned on again, started dropping. The dotted line is the proposal that has just been made to continue this standard through to 2030. And the proposal is that in 2030, the carbon intensity would have been reduced by 20%. Sorry. And these are all the fuels that are currently part of that system, including there's interesting things on there. You see electricity down at the bottom. We have electric cars, that counts. Ethanol is the large blue blobs toward the lower right. And the the original gasoline is set a little arbitrarily, but the orange line is the value, the carbon intensity for gasoline, and the value this year that you have to meet in California is 3.5% lower than that. That's the green line to the right of that. The further your fuel is to the left, this side, sorry, your left, the further it is, then the more credits you generate, the more money you make. So these large orange blobs over here are renewable diesel made from hydrogenating, basically, oil crops. Those are very valuable today, making a lot of diesel. That's growing and taking over more of the market. Remember that you have to mix this fuel in order to hit the standard, so that's why ethanol is actually becoming less and less valuable in California, because originally ethanol was only about 10% better than gasoline. They've gotten better. The average is better than that now. But these lower intensity fuels are basically pricing it out of the market. They're better because they have higher value. And every year that this standard has been in place, we've done better than the standard. And what does that mean? It means people were banking credits. They were obtaining these credits from the state for doing better than the standard and banking them. And those banked credits, just for a sense of scale, amount to about 9.5 million tons of carbon dioxide. This year, however, we only just met the standard, which means as the standard decreases again by a little more than 1% next year, there's a concern. Are we going to be able to meet it next year? And that's one of the reasons that the California Air Board, which rules this sector, has decided to start increasing the number of things that you can do in order to meet this standard, basically bring more technology into play. The price fluctuates depending upon availability, and there's a very low price sector when the oil companies were suing the standard. It wasn't clear the standard was going to move forward. And as soon as those lawsuits were resolved in 2016, the price jumped up to its design level of around $100 or around $120. If you ask the Air Board people what they wanted this thing to trade at, they would say $120 a ton. It's capped, by the way, at 200. You can't go higher than 200. However, as I said this morning, it's trading at 160. I think we can just say, okay, in the last few years it's been $120. That's what you can think about. Unfortunately, though, this is not fixed. It's dependent upon the market. So the new wrinkle this year is carbon capture and storage. Up to this point, you've been able to do lots of things. You can increase the efficiency of your system, but you haven't been able to actually take carbon dioxide out and put it underground and count that, mainly because there wasn't an accounting standard for which to do that. The low carbon fuel standard is all about accounting and not much about science. But they're paying a lot of money for this, so that's actually fair enough, right? The CCS Standard, which has been proposed, has now been tentatively approved and will be finally voted on in August. Basically applies to any process that you use to make a fuel that's going to go into California. Any process anywhere in the world for a fuel that's going to be sold in California. It means if you make your refinery emissions reduced, if you take CO2 off your cracker and put it underground, that counts. If you catch CO2 off a fermenter, put it underground, that counts. The putting it underground is a big deal. These standards are rigorous. They are the most rigorous standards anywhere in the world. Many of us have tried to counsel the Air Board not to make them so rigorous, and they've said, get out of here. It's more than $120 a ton. Anybody can do it for that kind of money, and I have to admit that is a lot of money. So, where are we going to see this early on? Things that have nearly pure streams. If you have pure CO2 coming off a fermenter, every ethanol producer in the United States is looking carefully at this right now and saying, wow, can I make $120 a ton of CO2 on something that was being emitted into the air previously? This is terrific because this is negative emissions. This is the thing we want to have happen. However, the facility is going to have to be near good storage sites because, again, these storage rules are rigorous. You're going to have somebody who sets up the underground storage site, and a lot of people are going to bring their material there. They get paid as a joint venture. The people who produce the CO2 and the people who store the CO2 have to approach the Air Board together with this joint plan, and that's who gets paid. And my co-author, Sean McCoy, and several other people have recently published a paper about what the expectation is for ethanol refineries in the U.S., and it's high. They basically think that at the prices we're talking about, pretty much all of the CO2 that's emitted by ethanol refineries in the United States could be captured and put underground, and they would still make a massive profit. basically at $90 a ton of LCFS price, you'd be able to capture more or less all of the CO2 in the US systems. That includes the pipelines and the storage to put them away, because if you followed ethanol in the US, it has this unfortunate situation of the ethanol refineries do not sit on top of the good storage saline reservoirs. They're all away, so you have to build pipelines. So we ask ourselves, can we actually get to negative? We're taking ethanol, which comes from mostly corn in the United States today. Is that really negative? So my co-author, Sean McCoy, has done an evaluation of this, and the answer is you start off with average ethanol today, has a carbon intensity of about 78 grams of CO2 per megajoule of fuel. If you capture the CO2 from the fermenter, the one in the middle, you can reduce that to 46 grams of carbon dioxide per megajoule. That's a big reduction. That's a lot of money. If you capture all of the CO2 in the process, which is basically the heat that's used to distill the ethanol, which is mostly done with natural gas today, you can reduce it to 29. Still not negative. Why is it not negative? Because of that big green bar, which is indirect land use. You can make whatever rules you choose about this. California has chosen to count indirect land use in the life cycle assessment of fuels. It's taken a middle ground on this. There are people who think you should do more, think we should do less. But the point is, this is the rules. If you want to get paid, this is what you have to follow. And that's the thing that keeps this from being a true negative emission today. Doesn't mean it's not a good idea and that we shouldn't get rolling on it. And that indirect land use is rolled up in the fact that farming's really hard to decarbonize. We've heard a lot about that. Fertilizer, all kinds of things make farming hard to decarbonize. And this is going to be a thing that's a challenge. And so the question is, do we want to get our biofuels from farming? Perhaps that's an answer. But today, about 10% of the fuel that's sold in the United States is biofuel, is ethanol, not included under the low carbon fuel standard. This is the ethanol mandate for the entire United States. And every molecule of carbon that goes into ethanol, there's another molecule of carbon that's emitted as CO2. Today it's ignored. They say, oh, it's carbon neutral. We can ignore that. Well, we should catch that and put it underground. That's the negative emissions, and that's what we're aiming to do. And if we did that in the United States with our capacity for storing for generating biomass, it's a big number. Basically, the Department of Energy in the United States has determined that they think the U.S. has a capacity in about 2040 of 1.5 billion tons of biomass. If we turn that all into fuel, according to the kind of mechanism we just talked about, there's a potential to capture, or to emit or capture 750 million tons of CO2 from that process. That's worth doing, especially if you can get paid the kind of money we're talking about under the LCFS. At Livermore, we've teamed up with Iowa State University, and we said maybe fermentation is not the best way to do it. Maybe pyrolysis is a better way to do this. Basically, the smoke that you see coming off this leaf pile is basically a condensable oil. You can do the same with lots of biomass. Turn it into an oil and leave charcoal behind, leave biochar behind. And forest biomass is a good place to do this because you don't have the issues, as serious issues as with farming. And in California, we have a lot of dead trees already that we need to get rid of, and so it's actually a benefit. It costs us $1,000 an acre to clear those trees for fire control, and maybe we can turn this into a positive thing. This is the kind of synergy that I think we all need to look for. Basically making transportation fuels instead of spending money to clear for fire control. The biochar you end up with can go back into soils. This is why one reason Iowa's soils are so good, because the prairie used to burn. It doesn't burn anymore. But the question is, can that bio-oil be negative? I have to tell you, we have not resolved this yet. We're going to do a large-scale test next summer and decide, do a full LCA and decide if that bio-oil that we make by that pyrolysis method can actually be negative, but we think there's good prospect for it to be negative, especially if we get to count the biochar. Unfortunately, under the current California standard, we won't be able to count biochar because it's not the kind of storage that they're talking about, but that's all right. When we demonstrate it, we can talk them into it. And we think CCS can have that kind of an impact on many of these fuels, basically a reduction of on the order of 30 to 35 grams of carbon per megajoule of fuel, which can make many of the bigger sources there carbon negative ultimately. So CCS is going to be an important source of negative emissions, but it's not hugely negative. It's just slightly negative. That's okay. We don't have any negative today. I'll take slightly negative. But the big news in the system that I want to close with is that the proposed standard, which will be finalized in August, suggests to use air capture to count it exactly the same as all these other things. This is pretty amazing. It's basically post-emissions capture. They're basically saying the fuel cycle ends with emissions, and if you can capture those emissions, we're going to count it as if it really, if you capture it over here on the campus here in Sweden, we'll say that's as if it was the same as a carbon dioxide molecule from California, and that's remarkably progressive for regulators. There are no constraints in the current system on where you do this. You can do it in the Seychelles, and the current proposal would include it. So, my conclusion, the low carbon fuel standard is a way to start getting these things happen and get people paid, and get people paid on the order of $150 a ton to do this. That's going to start some businesses. It's going to make some things happen. We're all counting on this final standard being approved in the fall, but frankly, many of the people who are involved in negative emissions technologies are expecting that will be. There are no substantive challenges to this proposal, and I believe that this is going to be available come fall. Thank you.